In this video, we're looking at the integral from -1 to 1 of x square root of 3 minus x squared. And I'm actually going to show 3 ways to do this integral. And I'll start with the way that I think is the best. And the best approach in this case is to recognize that we're looking at an integration interval that's symmetric about the origin. So I'm going from -1 to 1. So I start to think about the parity of the functions that I'm dealing with. In other words, the symmetry, the evenness or oddness. And x happens to be an odd function. And square root 3 minus x squared happens to be an even function. That means if I replace x with negative x, I just get back the original function. And in a previous video, and I'll post a link to this real quick, we showed that an odd function times an even function gives you an odd function. And in another video, we showed that the integral of an odd function on an interval symmetric about the origin must vanish. In other words, I get 0 by symmetry here. If we can solve the problem without actually grinding through the integral, that's the best way to do it. Now, the second way that I'll show is kind of an informal using the chain rule backwards. In other words, it's like a u-substitution, but glossing over a lot of the formal machinery. Now, what we're doing with a u-substitution is really just trying to make it easier to see the chain rule backwards. But in most cases, it's better if we can see it without the formal substitution. So I'm going to rewrite the 3 minus x squared in the square root as a 3 minus x squared to the 1/2 power. And then out in front of that, I had an x. Well, that's almost the derivative of the interior function there. And I'm going to make it the derivative of the interior function, which was -2x. And I can move constants freely in and out of the integral. And if I multiply the interior by -2, I have to compensate by multiplying the exterior by -1/2. So now I'm looking at some function raised to a power sitting right next to the derivative of that function. And this allows me to see the chain rule backwards. So I should get -1/2, and then I have 3 minus x squared, using the power rule here, to the 3/2. So just add 1 to the exponent, and then divide by that resulting exponent. And this is evaluated from -1 to 1. Dividing by 3/2 is the same as multiplying by 2/3. So the 2's cancel there, and I end up with a -1/3. And then when I sub in my upper limit, I get a 3 minus 1 raised to the 3/2, which is a 2 to the 3/2, minus a 3 minus -1 squared, which is also 1 to the 3/2, so another 2 to the 3/2, and then I see that my integral vanishes. Now the most formal way to do this integral is to do a u-substitution on the interior of that square root. This still is only going to work if the derivative of that u is somewhere else in the integral. So it's still critical that we have that factor of x there so we can get the derivative of the interior. So let's see what that looks like. We let u equal 3 minus x squared. Du, the differential of u, is going to be the derivative of that, -2x, times dx. And in this case, I'll just opt for manipulating the integral to get the -2x dx inside. And this is very familiar because I had to do the same thing in the previous solution. Multiply by -1/2 on the outside, -2 on the inside. My square root piece is now the square root of u, and I've built that -2x dx. So I replace now -2x dx with du, and at the same time I'm going to write the square root as a fractional power, and we use the power rule to get the antiderivatives. That's u to the 3/2 divided by 3/2. And I should point out here that the limits of integration are x limits of integration, not u limits of integration. And one way to do things at this point is to rewrite the answer in terms of x, and that would give us an expression just like what happened in the previous solution. It might be more interesting to go ahead and transform the limits of integration to u limits of integration, and then forget about x entirely. So if I look back at my substitution, let u equal 3 minus x squared, I think to myself, what's u going to be when x is -1? So when x is -1, the lower limit of integration, u is going to be 3 minus -1 squared, or 2. What about when x is +1? U is going to be 3 minus 1 squared, or 2. And we know what happens when the upper and lower limits of integration are equal to each other. The integral has to vanish. But if I can just get into a little more detail, clean things up by canceling those factors of 2, I get a -1/3, u to the 3/2, evaluated from 2 to 2. And of course, when you sub in the upper and lower limits, you get the exact same number, and the difference between those must vanish. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.